Good morning. I'd like to present this board, Audio 42250. It has 4 independent channels that are dry type relays driven by a microcontroller unit, and it can be driven by I2C as well as local push buttons. It has a specific, quite unique feature which I have designed. That's this bus. It's a kind of in-out bus. Direction isn't defined because it's just parallel ports, 4 lines, with ground, clock, data, and VSB. VSB is the V supply bus. That's a 7-volt line, which can come through any board, like this jack 5mm. But if we ring the boards with other boards by the sides, and we can go how many we want that are addressable on the I2C bus. This is I2C bus. A single point of supply will provide supply for all the boards, and the I2C bus will make them connectable from any point in the chain. This board is simple I2C addressed via this deep switch. 41 hex is the default address, and we can select by this switch 8 different address. So if we have multiple boards, they can have a distinguishable address. And likewise for this one, with a deep switch here, which can address 3 bits, so to select a unique I2C address. And this is MCP 23017, which is GPIO generic I2C device with 16 lines, actually 2 8-bus ports. This is how it works. The power supply is 7 volt from an external transformer, and we have back power to the Arduino board connected here, as well as I2C signals. And now there is a small demo program running that's just sending commands to open close the relays. That's simple as this. So this board actually listens for I2C. It listens also for the local push buttons. So for example, now if I want to control switch 1, I can open and close it, and it takes precedence, which is if we push here, the I2C bus goes silent until the button is released. And this is simple toggle mode at the moment. Very simple. That's how it works. We provide power supply 7 volts from any of the VSB, V supply bus. That's common 4-pin wired back to the other boards, and we can see that this board is now power supplied. If we connect the I2C, we make the program so that we will read or write from this board. We can access any of them on the same command bus. So this setup is very flexible. We can plug boards, and we can have a single point of access to all of them. So we can have quite complex design. At the moment there is a GPIO board, there is a relay board, and there can be also IO boards for analog devices or whatever, can be chained, and everything will be supplied on the same bus. So every board I design has this specific feature to connect with an FPC connector. So now I'll provide a little bit more details on the design of this board. We have 7805, which converts and provides 5 volt rails inside this board. From the 7 volt, we just need to be regulated, but it's better that it's not too high, because when we draw current, the 7805 will rise up in temperature if we have too high voltage on the line. So better to keep between 7 and 12 volts, for example. This is a dry type relays with 2 normally open, normally closed, and common 2 sets of them that are linked to every relay. Therefore we have 2, 4, 6, 8 channels, 8 contacts actually, but 4 independent channels. So we have 7805, we have the 5 volts on the top, we have ground plane below, we have a reset push button and 4 buttons to drive the relays locally. We have the port with some ground 7 volt pins as well as I2C signals in here. The same in here, which we can put a header and solder a specific header if we want to. And we have the port over here, which is similar to the push buttons, which is simply we can close ground to any of them, and it's as if we push on the buttons. So this board can be driven by push buttons locally, can be driven by push buttons, but we connect the push buttons remotely, can be driven also by I2C. In this case, we program a little bit on the, for example, an Arduino is simple, or Raspberry also works easily. And I have a demo program for I know file for Arduino at the moment. We have Q1 to Q4, which are simple MOSFET with a set of resistors, diodes that lights up when we have a relay activated and drive the current into the relay, which is 100 milliwatts. And on top of that, we have the interesting feature of this board. We have 2 crystals, and so we can run this 80tiny FOX61 by either the internal clock, which is accurate trim 8 meg frequency, but we can also drive with more accurate 8 meg crystal, and we have also 32 kilohertz for RTC, which means this board, the firmware, can actually handle sleep. So for example, it can be programmed to go into sleep for a while and do things at time. So the firmware at the moment supports toggle. It can also support pulse, and I will update the firmware in the future to make this chip able to be switched from mode that is actually running toggle mode to different modes. I plan to have 3 modes for that, which is direct contact. So either you toggle, right now you can toggle, or you can push and release to have the relay activate, or you can have a pulse. So when you push, you have a pulse, and the pulse can be a time that you program in seconds to something. 1 second to, there is no limit. It's too high to consider that a reasonable limit. And this we can program with the I2C, and when it's programmed, it will remain, the parameters will remain into the chip. So we can have a toggle for this one, a pulse for this one, toggle for this one, and whatever we want, through just a simple board that's connected to Raspberry. We say a few commands and the parameters are set. And that's all for it now. Thank you. This board I will put on the store. I put the link in the below the video. If you want to get it, it's about a little bit above 30 USD at the moment. And that's it. I hope you will want to try it. Thank you.